3-3, proving lines parallel. Problem 1, which lines are parallel if angle 1 and angle 2? Angle 1, I'm sorry, is congruent to angle 2. Now, there's a bunch of converses to the alternate exterior angles, converse to the same side, converse to the alternate exterior, converse to the corresponding. I didn't want to burn you with all those definitions, so really what it's saying is that the opposite of what it was. It says if two lines are parallel, alternate exterior angles are congruent. Well, now that's the opposite of that is if alternate exterior angles are congruent, then the lines are parallel. It's about kind of identifying which lines are parallel. So in this problem, it says that angle 1 is congruent to angle 2. So we got angle 1 congruent to angle 2. What line are those on? Well, those are on line M. So if they're on line M, what that's saying is because of that, what lines does line M cross? Well, line M crosses A and B. So therefore, A is parallel to B. Problem 2 is a proof of the converse of the alternate interior angles theorem. So we're given angle 1 right here is congruent to angle 7. We want to prove that L is parallel to M. Okay, so what we're going to do first is, obviously, if we need to get the alternate interior angles, we need to find two angles that are congruent. That will help me to do it. Now, again, what we're doing is we're proving that lines are parallel here, okay? So what we want to do here is we want to state that angle 1 is congruent to angle 7, and the reason given. Again, I should set up a better chart than this. Okay. 2, I'm going to say that angle 3 is congruent to angle 1 by vertical angles. Once I have that, now I can see that angle 3 and angle 7 are both equal to the same angle, so I can say that angle 3 is congruent to angle 7 by transitive. And 4, I can say angle 7 is congruent to angle 5 by vertical angles. 5, angle 5 congruent to angle 3 by transitive. And there's our alternate interior angles. I can say 6, L is parallel to M. Now I just showed you how the alternate angles are congruent. I just threw those in there. You could have stopped here because I just wanted to get the lines parallel, but I wanted to show you how I could get my 5 congruent to angle 3, proving that alternate interior angles. But line L is parallel to line M if corresponding angles congruent, lines parallel. So these are kind of two unneeded steps. I just wanted to show you how I could get to my alternate interior angles, the proof of the converse of that. But you could have stopped here because once I have 3 and 7 congruent, 3 congruent to 7, that makes my corresponding angles congruent, so my lines are parallel. Problem 4 is about using algebra to show the value of x that makes A parallel to B. Well, if I'm saying that A is parallel to B, what I'm saying is that all those properties hold true. So what value of x would make that true? Well, I'm dealing with same-side interior angles. We know that same-side interior angles, when I add them up, 2x plus 9 plus 111 degrees equals 180 degrees. Why? Because they're same-side interior. Same-side interior equals 180. So I'm going to combine like terms. 2x plus 120 equals 180. I'm going to go ahead and subtract, get 2x equals 60, and divide by 2, x equals 30. There's our answer for x that makes A and B parallel.